This
computer to talk to
conference will
anyone.
now be recorded.
And here we are in these strange times, and I'm not getting out from behind my computer to talk to anyone. So let's begin. Today I want to learn how to use PowerPoint. Talk to you guys about some observations from profiled mooring in the Southeast Bering Sea. This is collaboration through the EcoFoci program, the Innovative Technology ITE program, and the PMEL Engineering Division. So for those who aren't familiar, the M2 site, and this is Southeast Bering Sea. We've been deploying here for 25 years, celebrated this year. Congratulations us, woohoo. You can see on the bottom, I've kind of got a little bit of a time series here of occupation of the M2 site, alternating in colors because we deploy twice a year, a surface buoy for the summer and a subsurface buoy for the winter in order to prevent it from being taken away or destroyed by ice. Here on the right-hand side in green are the co-located 4 years of Prowler data that I'll be showing. And then off on the right is the scheduled, but currently awaiting our current situation for this year's coming deployments. We do anticipate putting out a Prowler again for the 5th season, which could prove to be interesting because the last 2 seasons have not had ice near M2 in the Bering Sea. 1 season did, and we can talk to that a little bit here. So as I continue, historic mooring design for our surface mount moorings, right? Discrete instruments every 3 or so meters from the surface all the way to the bottom, sampling anything from temperature to conductivity, salinity, chlorophyll, dissolved oxygen, and then occasionally PCO2 or other special experiments that are not consistent necessarily from year to year. Just wanted to give a quick glance here at just how complex our moorings can be from the diagram presented by engineering schematics. Jump forward here and talk briefly about the Prowler, this profiling crawler developed by engineering here, not specifically for EcoFoci, but we are found a good use for it. And effectively what it is a platform that will go up and down in the water column. It's wave driven. This is the platform itself. On the right-hand side here, you can see it opened up with a temperature conductivity cell in it. We also are capable of putting dissolved oxygen and a fluorometer on there. On the right-hand side here is my silly little animated GIF here to kind of give you an idea of what the platform looks like. It free falls and then wave action and buoy heave, which is not properly depicted. Slowly brings it back up to the surface. That same mechanism can actually help it crawl down. Any real exploration or questions you might have towards the mechanisms here, I would suggest going to EDD and ask them. And this is also a device that's been on to its next phase of its life with McLean Labs. But effectively, you can see here some of the details. It takes about 5 to 6 minutes to complete a profile in 70 meters of water at M2. We do about once an hour, roughly, therefore, 1 to 2 meter vertical resolution in the water. That's better than our instruments, which are placed about every 3 meters. It also has real-time communication, so we can see this data as it's being acquired. The biggest issues you have to think about for additional instrumentation is battery size and instrument size and battery considerations, power considerations. So with that, I want to just walk through and do a quick comparison here of some of the primary measurements from M2 versus the M2 standard mooring versus the Prowler mooring. Point out a few highlights here, and I think that'll end up being all of our time. So start with the thermal profile. This is something that we've actually been pretty good at capturing with 3 meter resolution. This is the standard PEGI M2 mooring. My notes have disappeared. Here we go. This is the Prowler mooring from the last 4 years. And then I'm going to drop down below and have our overwinter plus our summer co-located here. And you can, and I'm just going to point out some highlights here. This is the only year in our 4-year time span where we had ice at M2. Throw on the temperature, air temperature, relative humidity, and atmospheric pressure, and you can see, I lost my mouse over here. This past summer, there was a pretty significant heat wave in Southeast Alaska, and the highest temperature ever recorded in air at M2 during our 25 years out there. And you can actually see that heat transfer into the upper water column, and as it is mixed down through the summer, I'm sorry, here we go. So really, like I said, temperature is something we've been pretty good at. Resolution, you can see it's a little less fuzzy with the Prowler at its 1 meter resolution, but we've done a good job of capturing the temperature thermal profile at M2, and we continue to do so with the Prowler. Salinity, on the other hand, is a measurement that's significantly less resolution in the water. We are able to capture the 2-layer system in the mixing, fall mixing, but we don't really have a high resolution picture of it. But you throw the Prowler data in there, and we start to get a much more enhanced picture of the salinity and therefore the density profiles, and some challenges here that still need to be taken care of. The spikes right here at the thermocline, that's a known challenge with conductivity cells going across sharp thermal gradients. And so part of my role here is to help quality control that out. We're going to jump to 2 other instruments, chlorophyll and dissolved oxygen, and this is where the Prowler has really started to shine the last couple of years. We've gone from maybe 1 to 3 instruments over the entire water column to having a complete picture, especially so in the 2017, 2018 summer here. We would have missed the spring bloom. You can see it just at the tail end of April of 2017. But we see this feature here. Remember, this is the year that had ice. We see this feature here that if we had only had our standard chlorophyll measurements, we would have missed the top of it, and we would have just had the bottom here. So the Prowler has really opened up the ability to explore the spring blooms here and look at patterns from year over year. Same is true with oxygen. I can speak to the oxygen a little bit more, but Jens Nelson, another one of the leads here, he's doing some exploration into developing productivity metrics in using the Prowler oxygen data. And so a presentation by him at a future point will do a better service of how that data is being used. And so finally here, just in my last couple of minutes, I wanted to throw all of the parameters up all at once and just draw the attention again to the resolution differences between our overwinter here. There's no Prowler, and it's this representative kind of our capabilities before, and the picture that you see during the Prowler deployments, and just the enhancement in the structure in time and vertical space that this platform provides for us. So some future explorations with the Prowler that we're playing with here is near real-time metrics for heat content in the Bering Sea. We don't have to wait, since this transmits data in near real time, we don't have to wait until recovery in order to do analyses. The Prowler itself has dynamic programming, so we can change our sampling strategies while we're out there. As mentioned, it's being explored to a primary production metric by Jens. And I haven't spoken to it at all, but we are just now trying to get a better handle on the way the oxygen sensors handle the sharp thermal gradients. They have challenges in response, much the same way that salinity does. And we had planned for kind of an intensive operations and exploration period this year with a suite of oxygen sensors. Again, given the current state of our society, we'll have to see what happens there. And then, of course, since QC/QA is one of the main responsibilities I hold for EcoFoci, trying to figure out how to best analyze this data, since it's an order of magnitude more than what we were previously getting, is a exploration that I continue to work with. Since I mentioned data, really quickly, for those who don't know, I myself, Peggy, and Phyllis, we're all probably your primary points of contact for EcoFoci data. I have some internal data services that I'm working with our data integration group to help develop this, the ERDAP services. And I just wanted to say, if you're intrigued in what you see here, or want to help explore some through collaborations, then to contact myself, Peggy, and Phyllis, and we can go from there. That's all I have in my quick couple of minutes. Some extra slides later if somebody has any additional questions, but I believe at this point I will hand the presentation back off to Heather. If I can.
Thank you, Sean. It's okay. I'll take it back.
Good.
You don't. If I can find our own name in here. To start with, and so for you guys who have questions, as I unmute Sean and swap back to him. All right, Sean, screen should be shared back with you.
Yep.
And I'm gonna read out the first question that I see for you, from Dong Zhao, who says, nice talk, everyone. Sean, I suspect the sharp spike salinity in the Prowler profiles right underneath the isothermal layer is an artifact that can be removed by screening temperature profiles to make sure correct temperature is used to convert conductivity to salinity. I guess that was more of a comment to the question.
No, and Dong Zhao, you're absolutely right. This is a known challenge with conductivity cells. It's a thermal lag in the cell, and so as the instrument transitions from very warm to very cold water, or vice versa, the conductivity cell and the temperature are not in phase, and that leads to an over or underestimate of the salinity. And usually when we're doing, an order of 100 CTD casts in a cruise, that's oftentimes easy to manually double check. When you're doing 24 profiles or more per day over the course of a couple of months, then some automated QC/QA analysis utilizing transition thicknesses or temperature comparisons is absolutely the direction to go. And there's work that's done there with gliders and whatnot that are also trying to explore that, and we're trying to use lessons learned there to improve the data set. But you're absolutely right.
Thank you, Sean. Any other questions for Sean or anyone else? Please put them in the chat. Just want to say thank you to all of our speakers, Sean, Peggy, and Dave. Certainly was fun to try and do the lightning talks in person, and then having to move that to virtual seminar was quite the feat. But it was really fun having kind of these shorter snippets to hear what everybody's working on. Jens, have you seen any other questions that I've missed?
No, there's.
Okay.
Any other ones? A couple just came in now.
Okay, so Megan Cronin has a question for Sean. Sean, are you still unmuted?
I am, yes.
Megan's question is, my understanding is that you have 2 moorings during summer, the standard fully loaded surface mooring and a second surface Prowler mooring. Are you considering transitioning to using just the Prowler during summer?
That's a good question. I've asked Phyllis some similar questions from time to time, and I think you'll get a best answer from her, but I'll just say that the first couple of deployments were part of the ATE project, right? The innovative tech usage. So a co-location, just as a comparison, was prudent. Of course, the Prowler has its weaknesses. The primary one being that if the actual unit itself fails, then you have you've lost all information for that water column. And I think if you compare that to the old school discrete 1 instrument every 3 meters ideology, there's a little bit of hesitation there to rely on it solely just because of that, but that's just a consideration that has to be taken into account. And then the other challenge is that the Prowler is not capable of housing every single type of instrument that we put out there. You wouldn't put a nitrate sensor on it at the moment. So to answer your question explicitly, that would be a discussion point. That's a good question for a program going into the future. It definitely does a lot of the same work, complements it in a lot of ways. But again, it is a slightly different platform, so its deficiencies and superiority would have to carefully be weighed for that year.
And then I'll add to that too, Megan. Phyllis has talked about this pretty extensively, actually. But we are with ITE also designing another mooring for the Arctic. And so she's sort of waiting to see kind of the steps with that kind of new Prowler mooring, modified Prowler mooring, to see how that works. And if anything, would eventually like to implement the system into our 70-meter line. But I think we're a few years off, a couple more years of testing, but it's definitely something she has talked about.
And Phyllis just chimed in saying, yep, Prowler only at some point in the future.
Perfect. I was like, I know we've talked about this. There's just some comments in here, general ones you guys can read through. Hi, Phyllis. Any other questions for our three speakers today? Give folks just a second. Again, thank you everybody for joining in. It's nice to kind of see everybody here with Seminar and Connect. We have a break next week, and as Jens just posted in the chat what our upcoming seminars are. And if folks have missed these or parts of them, we have been recording them. So it's up to the speakers to want to share that. But if you do have that request, please send it to Jens or I. And again, thanks everybody for joining in. I hope everybody's somewhat staying sane and we haven't reached picture number 10 on Dave's Defoe meter. Yeah, and thanks Peggy for asking that too. Please let us know any feedback on this lightning talk format, how you guys felt about getting snippets of our amazing researchers and anything else that might be on there. So please send those comments back to Jens and I as well. All right, everybody, I think I don't see any other questions. So if folks do have them, please type up with the speakers directly, or you can use Jens and I to go that way. Yeah, and we will see everybody in 2 weeks. Stay healthy, everybody.